Hello everyone. In this video, me and my friend will explain to you about our machine learning project assignment in artificial intelligence lecture with the topics is predict the successful rollout of PPNC in Indonesian regions from institutional geographical. So may I introduce myself? My name is Arya Raditya Ardana and my friends is Banyu Ranu Basuhjiwa. So let's get to introduction. With a particular focus on BPNC program to fulfill the global aims of SDG 11 Sustainable Cities, this study tackles Indonesia's urgent needs, effective social assistance distribution. Through a data-driven approach, this study seeks to close the gap between policy and execution by examining how institutional, prepared, and regional consequence affects aid delivery. In order to make sure that social safety nets are inclusive and sensitive to the particular difficulties faced by various Indonesian provinces, the study highlights the significance of using localized poverty measures. Now, the problem statement. The first one is data complexity. The criteria for eligibility for assistance are relative because each province has different poverty lines. Then the second one is distribution efficiency. In certain places, a lack of priority mapping causes logistic backlogs, while in others there are shortage. Then the third one is technical requirement. To swiftly identify distribution priorities, a classification model that can analyze actual data from field surveys and PPS is required. Then next to dataset details. Our dataset is a comprehensive dataset that's combining real-world distribution surveys with official Indonesian poverty measurement powers the analysis. In particular, in particular, it incorporates a survey describing BPNC and Rastra Assistance Programs or Basuhjiwa with provincial poverty lines data for PPS to create regional economic threshold. The dataset offers strong empirical basis for the model to precisely identify the prioritized high-need communities by concentrating on important characteristics like the poverty index, which compares household income to regional poverty limits, along with the dependency and job status. And we also include the source link in the slides. The first objective that we have is constructing a logic regression model from ground up to forecast the likelihood the PPNG rollout would be successful. The second one is examining how recipient eligibility is affected by geographic characteristics in the poverty index. Then the third one is creating a decision support capable of determining which location have the most logical requirement.
Methodology. For this project, we chose logistic regression. We picked this because it's the gold standard for yes-no questions, like whether a district will adopt a new program or not. So first, we programmed the sigmoid function, which is essentially the translator that turns complex data into simple probability. And to make the model smarter, we used gradient descent and check it for an epoch of 2000. So when you look at the learning curve on the right, you can see the process in action. The big drop at the beginning shows that the model quickly figures out the pattern in the Indonesian survey data. By the time it reaches the end of the line, it has become incredibly accurate. And finally, to make sure that data was clean, we removed any missing information and normalized the numbers. Okay, next is the results and matrix. In the results, we see minimized loss functions that reach 0.3382 by epoch 1800, and through the KPI, we see that the accuracy is 99.2 and a recall of 100 and F1 score of 99.60. The primary indicator here is that the local institution type was the most significant feature with a weight of 4.20. 8. And I will show a little demo here. So here is the code, and if we run the code, we can see the epoch is running here. On each iteration, it shows that it's going lower, showing that the machine is learning with more accuracy. And here we see the accuracy of 99.2 and recall and the predicted BPNT. For the validation of that data, we see that high accuracy can be misleading, especially with imbalanced data sets where most regions have already adopted the program. And to validate that these weren't just lucky guesses, we use 80 to 20 holdout split, testing the model only on data it had never seen before. And I also generated the confusion matrix integrity to verify that the model was not falling into the accuracy paradox, and the matrix confirms that the model is robust. And lastly, for the conclusion, this project proves that the transition from physical rice subsidies to digital vouchers isn't random. It is mathematically predictable, and by identifying that local institutional types are the biggest predictors of success, we can actually help policymakers target specific districts that needs more administrative support before a rollout. This is a practical application of artificial intelligence that directly supports the UN SDG Goal 11 and creating more resilience and technological ready communities. And that's all for our presentation. Thank you.